Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Testing Software is Awful, Here is How We Can Fix It, are my two wonderful colleagues, Trisha G. and Brian Demers. Both are Java champions and advocates at Gradle, but one is an author of an excellent book on IntelliJ, and the other is a beekeeper whose hives make seriously delicious honey. We'll leave it up to you to figure out who does what. So today we're having an open conversation about testing software, and namely why it's already hard and about to get even worse with AI-generated code and tests entering the picture, as well as some best practices and technologies for helping your testing experience. In today's session, we strongly encourage audience interaction, so we'll be asking you a total of 3 poll questions during the discussion, the results of which we will share as soon as possible. And these will appear on the screen for you to respond to. Trisha and Brian will also address relevant questions throughout the conversation, so add those in, and we'll be finishing up with a lightning round of questions for our speakers. Finally, this webinar is brought to you by our DPE Summit sponsors, who are Netflix, Uber, Meta, Intuit, and of course, Gradle. If you're interested in attending this year's DPE Summit, which is on September 23rd to 24th in San Francisco, please visit dpe.org for details. Tickets are only $349 right now, and they will be going up in the coming months, so now is a good time to save your spot. All right, that's it from me. Let's hand it over to Brian and Trisha. Hi, team. It's great to have you with us today.
Hello. Thank you for having us. Yeah. And the motivation for this webinar was that Brian and I just spend all the time talking about testing and what goes well and what goes badly. And we thought we should do this in public.
Yeah,
I agree.
When I run into it, we basically sit around and talk about this. So we figured we should do it a little more formally.
Right, exactly. And let other people get involved as well. So I guess our first question is our first hypothesis is everyone hates writing tests. And we kind of want to know why that is. So while Brian and I talk about what we hate about writing tests, maybe you could put stuff in the webinar chat to tell us why you hate writing tests or why you love writing tests or what you find hard or what you find easy. So Brian, why do you think developers hate writing tests?
I think because they don't have tests to start with. I think a lot of folks working on big legacy code bases or where testing hasn't been at the forefront of development, it's really hard to add it in after the fact. I'll admit I actually really like writing tests. It's not for the sake of just writing tests or just hitting fictitious code coverage numbers, but actually seeing how the code that I'm writing is being used and working. That's how I think about my code is from writing tests. But I've definitely worked at places where there was no tests, and it was painfully frustrating.
It is really hard to write tests for code that has not been tested in the past, particularly if you're talking about unit tests or sociable unit tests, right? Because I worked at a place, a nameless big investment bank, where there were no tests. This is a long time ago, but there was no tests. And I spent probably about a year trying to figure out how to create test harnesses and mocks and things because, these applications had singletons, they had God classes, they had weird interactions between different modules. So you couldn't just test a single class because you had to kind of inject all this other stuff. And so if you don't have good dependency injection, if you don't have good separation of concerns, good isolation, then it's really hard to write good tests.
Yeah. And then your tests they take forever to run. You can only run one at a time. Your test code probably looks like crap. Cause it's kind of an after the fact thing. And it's hard to get in that habit unless you start. Now, I will be the first to admit, I feel like it's an important exercise to go through that painful period. Writing those first 1 or 2 tests is going to be excruciatingly painful, but then it gets easier after that. That first one is definitely the hardest when you're figuring out, like you mentioned, how to mock things or how to structure your test to access your code. And then the next one's a little easier and the next one's a little easier. And then eventually it becomes something you can do.
It also improves your design, though. My experience when I worked in a place where we had really good test coverage and we did a lot of TDD as well, the design was very modular. It was very separate because it was designed for you to test it. So it was easy to kind of plug stuff together, and it's easy to repurpose stuff after the fact because it had been designed effectively with APIs. Even though we weren't doing like API design, the test has to call your code. So there's a kind of API that it calls. And you tend to think about usage in terms of if you're trying to test, I don't know, the order class, then you want to figure out, if I'm placing an order, what sort of information would I have to place that order, instead of doing it after the fact and you're testing, how does place order work, and then you're going, we never put anywhere for quantity because we didn't think about that.
Yeah, I definitely think that the act of writing tests, ideally beforehand, or while you're running your code, makes your tests more succinct. It's easier to write. The tests end up being easier to write as well because you're testing, hopefully smaller chunks of code as you go through, and you don't need these big God objects, or hopefully you don't need to spin up 18 singletons to do things in databases and whatnot.
One of the other things I think about, like if you're coming to a code base that doesn't have tests, not only is it difficult to test architecturally, if you don't have loads of experience writing tests and there's no tests to kind of look at as a starting point, it can be really hard to know where to start, especially if you've got tangled code. But even if you don't have tangled code, if you say, write some tests for this, and you haven't seen good tests before, it's really difficult to know what a good test looks like.
Oh, I totally agree. I used to write really bad tests, and I didn't care, right? So I when I was a little more green, but I didn't know what a good test looked like, for one. I didn't care that I needed good tests. I figured that testing was not really the main function of what I'm doing. I write whatever code, that's what we're shipping to customers, and the testing is just sort of there because testing is important. I sprinkled it through. And this is still when I thought I understood the need for testing, but I guess I didn't appreciate the test code. So I do all kinds of things like, didn't close file handles because it didn't matter because I was on Linux and not Windows, and all this other, like, just the test code smelled everywhere. And it was years later when I realized that that's definitely not the case. It, like, the test code is as important, if not more important than the rest of your code.
Yeah, I agree. I think it's really easy to fall into the trap of going, oh my God, I don't have time for the testing, and I don't have to be as clean with my testing code. It will get started up and torn down, so it doesn't matter. And granted, we don't want to spend forever polishing and shining our test code, but it does make me wonder, why are we okay with writing shitty code when it's the test code? Like, if I'm writing code, I don't want to write shitty code. I want to write good code. I want to feel proud of my code. The more we get into the habit of writing good code wherever we write it, the faster we're going to be at writing the good code, I think.
Yeah, and then, it comes down to when do you use your test? Well, you use your test for hopefully giving you confidence that your build works and everything, but also when you're trying to figure out some issue. Like, okay, this test is failing. You're going to spend a lot of time figuring out between the test and the code that is being tested. You're going to spend a lot of time there. So if your tests look terrible, it's going to be harder to troubleshoot and figure out what the problem actually is.
Yeah, I think we're going to talk about that a bit later on. Well, that's kind of a key motivating factor to writing more descriptive tests, because when you come back to a test that you wrote that you did in a less than optimal way, and then later on you're like, I don't know what this test is or why it's failing. Who wrote this? What idiot wrote this? Oh, it was me. I'm having a quick look at the webinar chat, and there's quite a lot of stuff which I think agrees with us, which is nice. And there's other people. There's people talking about this thing of, like, which we felt, the pressure to deliver. Oh, I don't have time for the tests because I have to write the code, and it's such a common thing to feel pressure to deliver the code and not the tests. And it feels like a really normal and obvious and logical thing. But the problem with common sense is that common sense isn't necessarily always correct, right? So you skip the tests now. And like you said, in, maybe a week's time, maybe 6 months' time, you're debugging a problem in this area. You're like, oh my God, I really wish I'd had some tests, because the debugging is now taking me 3, 4, 5 times longer than if I'd had some tests that maybe might have failed at the right time, or maybe at least tell me what the functionality should do.
Yeah, and it's still the typical story. We've all heard the story, right? Like testing speeds up your delivery because the things you ship are tested, so you know they already work. But sometimes we try to get ahead of that. I'm like, oh, I did some manual testing or whatever, and something sort of works. But the confidence you have in that change just isn't as high as if you spent a few minutes writing tests. And that's really what's going to speed up the whole process. So pushing test off may actually is likely slowing you down. So taking the time to write the test as you're coding, not after, but as you're writing code, in your definition of done or whatever you want to call it is a way to get ahead of that.
Just humans are really bad at thinking about medium to long term, though. We're just not designed to think that way, right? Like not writing your tests is a bit like having a chocolate bar right now and going, oh, well, I'll go on the diet tomorrow. And then you never go on the diet and you never eat more vegetables and, and your health suffers. But today that chocolate bar looks really good. And tests is a bit like that. And I mean, some of us who like writing tests find it addictive to get that nice, red-green refactor kind of cycle, particularly with TDD and things like that. But it's really difficult to overcome that thing of, oh, but the code works. Let's just ship it and move on to the next thing.
Yeah, I mean, that feedback cycle, like I mean, we'll probably talk about this a little later too, but I write a test in my IDE and I click that little go button and hopefully the response is almost instant. Right. And my brain gets that little dopamine and I'm ready to go. I'm super excited about it. So I feel like that keeps me in kind of a, positive state and just kind of keeps me in the zone more.
I love it when something tells me I've done a good job. If the IDE gives me a little green tick, I'm like, yes, I did a good job. Let's move on.
Yeah. Even a test failed like early on is still good. I mean,
yeah,
it's not great, but it's still telling you that whatever you're doing is at least failing. And that could be the indication you need. Well, obviously that code didn't work,
Yeah, and sometimes I use failing tests as my to-do list. So I'm like, because I'm quite often thinking about 16 different things I need to do at once, not very focused. And so when I'm thinking, I mustn't forget about this and I mustn't forget about that, sometimes I'll sketch out even just a test title. It doesn't have to be the full test. A test title that fails to remind me, come back to that. You've got to make sure that works. And then, I'm not going to lose the plot.
I think the test that fails is the key bit. I don't know how many times I've come across test code where there's just a test method with a name. It's a great name, good descriptive test name with an empty body, right? That's not really the to do because that's just a placeholder that at least looks like it's there, but when you dig into the test code, it's not actually doing anything.
So I wanted to move on to my next favorite thing in the testing area, which is flaky tests. So we have a poll about flaky tests, which hopefully Oliver will pop up. Right, flaky tests. We're going to ask you if you have flaky tests. So Brian, tell me what flaky tests are.
Well, hold on. So someone gave me this cool shirt. So first off, right? So it's this, right? So
I was supposed to wear mine today and I forgot completely. I was like, I'll just wear a white t-shirt.
Yes. So Trisha made the shirts, and the image I think is on your website, right? Yeah, so we can point you to, if you want one of these shirts, we can point you to the image later. But yeah, so a flaky test is essentially a test that passes or fails intermittently, right, without any code changes. So maybe you run it once and it passes, you run it again and it fails, or you run it once and it fails, and then you run it again and it passes. That's essentially a flaky test. It's non-deterministic at some point. Maybe it's every 10th time it fails, maybe it's every 100th time, but there's some inherent flakiness in there.
Right. So if you've ever decided to rerun a test after it failed, then there's some inkling of you in your head that test or your test framework is flaky.
Yeah, and it erodes our trust, right? So this is the typical question that I was asked, right? Is if you have a pull request and the CI build fails, what's the first thing you do? Do you open the log and see what happened? Or do you just say, click the rerun button, right? So and I know sometimes those are build related, not test related, but oftentimes it's test related. And if you're just rerunning the job, you essentially don't trust your build because you have flaky tests.
This is my problem with flaky tests. I mean, I have many problems with flaky tests, but the main thing is that, like I said, I like my little green tick boxes. I like, when the test goes green, then everything's good. What I hate is, especially in CI, when you're running lots and lots of tests, and the idea is that after running your whole test suite, and you might be running a series of them, your acceptance test, your performance test, your whatever, you really want to know at the end of your continuous delivery pipeline that every test passed and everything's good to go. And if you have any flakiness, then you can end up with a CD pipeline, which is always red. But most of the time you're like, oh, it was probably those flaky tests. And you just go with it. But you have no idea which of those tests are really failing. And if they are really failing, you don't know if it's your test framework or if it's your production code or if it's the data. And so you just have this kind of vaguely uneasy feeling about all your tests. So you spend all this time writing tests, presuming you have tests, obviously, and then you don't really pay attention to the results because they're not trustworthy.
Yeah, so you could end up shipping buggy code, essentially, or maybe one common problem is like race conditions, right? So maybe the flaky test is actually a race condition or some other logic in your actual code that's actually a bug. But if you just rerun the test, it doesn't manifest itself. So you could be shipping buggy code. Obviously, the test could be problematic, and that's what we usually say, right? Oh, it must be the test. Like, I'll just rerun it. So it's not a great situation to be in where you're always just rerunning things blindly without thinking about it.
And it wastes your time, and it wastes the CI time and money, and you don't really know. Like you say, you don't know what it is. When I worked, I knew this was going to happen. It's my delivery has just come. Why don't you? Brian,
now might be a great time to share the results.
Yeah, and show the test dashboard as well. I'll be back.
All right. So while we're waiting for Trisha to pick up her package, we had talked about this early on. You know how it is. Everyone's working from home, or at least we are, and you get a package during an important meeting, and that's what happens. So 71% of folks think they have flaky tests. 19% of you say no, and another 10% are unsure. So I'm going to posit that everybody has flaky tests. There's always some inherent flakiness in the code you write. The ideal is to keep that as low as possible, right? Obviously, we want to be zero. But I'm interested, and you can put it in the chat. The people who answered no, I won't judge you. It's fine. How do you know you don't have flaky tests? Are you tracking it? What makes you confident that you don't have them? And then when Trish comes back, we'll show some data points from some real engineering teams that pretty much prove that even great engineering teams have flaky tests. One person said UI tests are flaky. That's a whole category all by itself. We could talk about just issues with flaky tests. Another comment. No tests means no flaky tests. Okay, that's fine. I think maybe 19% of those folks don't actually have tests. So that's one way to get rid of the flakiness in your code. I know my personal the development I do on even open source projects. I have flaky tests. I was convinced for the longest time that there was a flaky test and it was not my fault. I couldn't figure out what was going on. So I just keep running the test. And then, sometimes it would fail. And then eventually I really sat down and dug into it. And it was the order of the test. The tests were running in somewhat random order. And depending on the order they ran, the test would either pass or fail. So it ended up being that the test code itself was problematic because there was some state dependence between the tests. And that was easy to fix. But, those are the easy cases. And then obviously like race conditions and things are very much the opposite end of the spectrum.
I'm back. What did we show? Did you show the...
All right. No, I was waiting for you. So I was just commenting that everybody has flaky tests. And
right.
I think the biggest feedback was if you don't write tests, you don't have flaky tests.
That's fair. That's a fair point. I wanted to show a couple of things. One, let me just make sure I'm going to share the right screen. Every time I try and do this in Zoom, the button disappears off the thing. Firstly, I wanted to talk. So one of the answers is, how do I tell if I've got flaky tests? So we said that flaky tests are tests that sometimes pass and sometimes fail, right? So under the same circumstances, they'll pass and fail. So one way that you can determine if you've got flaky tests is you can set you can use your build tool for this, whether it's Gradle or Maven. You can tell it to rerun failing tests. So if in the same test run, a test fails and then you rerun it and then it passes, by definition, it has to be flaky. It's working on the same environment with the same code, with probably the same data, one would hope. So you can flag that as flaky. And then what we do with Develocity, we use this to determine how flaky your tests are. So if I show this is the Spring instance. So if anyone wants to go and have a play with this, it's available because we give it to the open source Spring software. Should have warmed this up beforehand to make it look much faster. And so then you can tell which builds have got flaky tests, and you can order your tests by flakiness. This is one of my favorite things about Develocity. This is actually why I came to come and work for Gradle, because it's cool. And so then you can see which tests are flaky. This one, it passes a bunch of times, but it's flaky a bunch of times as well. And it's not surprising because it is an integration test. So often you'll find that integration tests, we've got Docker tests, we've got servlet, web server, factory. You can tell this is Spring, right? Database type tests, integration. These are often your flaky tests. The more pieces you have in your test, the more likely it is to be flaky because there's more things to go wrong, particularly if you've got to start up a database or you're talking to a third party or even one of the services that you control. If you've got integration tests, there's just much more of a chance that they're going to be flaky. So, and there's another way that we can tell if a test is flaky. So in Develocity, we do it with retries, but the other thing you can do, if I can find an example, so we flag it two different ways. It says flaky if the retries passed and failed in the same run, and we do a little circle with an F if it's cross-build flaky. So you can also look at the same test across multiple builds, and assuming that the platform is the same and the code is the same, but your test result is different across builds, you can flag that test as flaky. So you don't have to use Develocity for this. You can use your own system, which I did at my old place. But then you probably spend just as much time maintaining your own software as finding flaky tests in the first place.
Yeah. So one of the things I want to point out is the retry, right? So Trisha had the Gradle and Maven options. So I think those are great options to turn on because they help you detect the flaky tests, right? But that's only half the problem. Right. So finding your flaky tests is obviously, the number one thing you want to do. And then you should probably fix them once you find them. Right. Don't let them linger.
This is my big thing. I in a lot of places, just finding the flaky test is it's not really failing because it's flaky. And okay, it's not failing. A failing test you should do something about. But a flaky test, you still need to do something about it. You might even delete it. I mean, it's a bit controversial, but.
Yeah, we should talk about deleting tests after.
Yeah.
But yeah, so think about how if you have a build failure now. I've worked at shops where if they have a flaky test, basically the test is flaky enough to get to a point where it's affecting all of engineering, right? So what do? They send out an email to everybody. How often do you check your email? Or maybe it's a Slack message, right? How often do you do that while you're focused on things? So maybe that disrupts your PR pipelines or whatever it is. It's really getting in the way. So turning on these flags do give you a little more space to continue, but it's definitely not something you just turn on and forget about.
Yeah, so you need to have a strategy for fixing flaky tests. I've been thinking about this a lot because I care a lot about flaky tests. One of the things is if you make a test start to be flaky, either because you created a flaky test or because you're working in an area and you made the test more flaky, it's really part of that piece of work to fix that flaky test there and then because you basically made it worse. More often than not, of course, what happens is that we trip a flaky test. It's not our fault. It's always been flaky and no one feels ownership of it. And that can be more of a problem. So one of the things I like to suggest is that those get sort of quarantined somewhere else. So you either run them somewhere else, you run them in their own build, or we used to put an @ignore until annotation on those tests. So they would be ignored for the next 2 weeks, giving you some breathing space to hopefully fix them. And then, if you don't fix them, they pop back up again in 2 weeks' time to remind you to do something about them. And then you can also do things like you can schedule flaky test days like we do at Gradle. So I can't remember how often they are, Brian. Is it once a month?
I think it's at the end of every release cycle, if I remember right. So basically, the build tool team and the Develocity teams kind of do the same thing, and of course, they triage flaky tests as they come up too. But essentially, take a day or two after whatever release, you're building up to a release. Hopefully, your releases are uneventful, but usually, what happens is you're building up to a release. You spend a bunch of time, you get the code out the door, and then you breathe for a minute. And then in that minute, you can spend time fixing your flaky tests. So if you have a dashboard like Trisha just showed, you basically sort by flakiness, and then the whole team can start at the top and work their way down. And I always say this does two things, right? So this teaches your team to fix them, right? Stabilizing the build, which is valuable all by itself, but it also teaches everybody that flaky tests are not something we want to keep around. So it's imparting that behavior, it's kind of a cultural that will help you fix tests as you find them.
And if you have a flaky test dashboard like that, I mean, however you want to come up with the dashboard, it does give you a nice to-do list. So you can just, tackle the worst offenders first. And I think there's a few different ways to slice and dice it as well. So obviously a test which fails very frequently, you probably want to fix that one. But also if you can scan that list and you think, oh, maybe 6 of these tests all look like they might be the same problem, then, you can tackle what you think is the root cause of that problem.
Yeah, if all the tests have database in the name,
Yeah,
exactly. Right, it's probably some sort of connection issue. Maybe your timeouts are too short, or maybe your infrastructure isn't coming up as fast as it should, or who knows what it is, right? But there's definitely chunks you can probably eliminate whole swaths of flakiness by finding common patterns.
I just want to have a quick look at the chat, see if there's anything in here. There's a whole bunch of stuff about flaky tests. Maybe we'll come back to that at the end because we've got other I really want to talk about testing best practices, and we've still got slow tests to do before we get there. Oh my God, we only have like 15 minutes. Slow tests are bad. You probably shouldn't have any. Should we move on to testing best practices?
Yeah, well, let's let's pop up the next poll, and then we'll talk about testing.
We'll talk a bit
practices.
about slow tests. So I always thought that the fact that tests take a long time to run is going to be a problem for a lot of developers because you have to hang around and wait for them. But when I've kind of polled people about this in the past, they don't seem that bothered. I think perhaps because you can set them off to run in your CI environment and then you can multitask and do something else. What kind of worries me about multitasking is that, you're basically doing a bad job at everything. And if something breaks, then you have to switch contexts and it just kills you to do that.
Yeah, there's always the feedback loop, right? So, staying in the zone. We've all heard about this or talked about this, or hopefully we've all experienced this. But if your feedback loop is 2 hours, right? By the time you make some change, push it to CI or push the PR, that CI picks it up. It's in the queue. Eventually runs. You get an email about it. You're on to 3 different tasks before that, right? So you've forgotten about it. So then you have to basically remember what you're doing and go through this whole process again. It's very inefficient.
I hate the context switch. It just kills me. And if anyone interrupts me when I'm halfway through doing something, then I'm just lost. Which is why actually webinars are quite difficult because I'm like, I'm trying to read this and I'm trying to talk to you at the same time. And what's coming up in the next poll? It's tricky.
Exactly.
I wanted to. Sorry.
Oh, I was going to say one of the comments is the poll is in the wrong units, right? So we had talked about putting hours in here too. So I'm assuming you're not talking about seconds, you're talking about hours.
I'm kind of pleased actually that what we're seeing so far is the majority of people have a build which takes more than 20 minutes. Because I've given talks about testing to big organizations and I've just kind of assumed that the build will take over 20 minutes because they often do. And lots of these people I talk to have like 3 or 5 minute builds, including tests. So I'm like, oh, well, that's not quite so painful. But I'm quite happy that 45 people have got more than 20-minute long builds. It feels more indicative of what the real industry is like.
Yeah, but it's interesting when I ask the question of like how long your builds. Not like we've asked how long your tests, right? But usually I ask how long your builds, and they're like, oh, they're really fast. Yeah. And then unless they turn the tests on.
Yeah, exactly.
And I always think of the build includes tests, right? Like that's your build time.
Yeah, no, totally. And actually, so there's some good points in the comments. When I worked at LMAX, we had a lot of tests. We had what we call the commit build, which would run the unit tests and the build, and that was a 6-minute build cycle. We had acceptance tests and performance tests. The acceptance tests ran massively parallel and would run in about 40 minutes. So you would get, in under an hour, you would get feedback for all of your tests effectively. And then performance tests and load tests and stuff, they would run kind of like separate to that. You'd get sort of regular feedback on that. But yeah, I can imagine that if you're running those kinds of test suites and you're not parallelizing them, or you're not, you don't have the infrastructure to run them correctly, I can totally see people running these things overnight for the whole test suite, at least overnight.
Yeah, absolutely. I'm sure there's a few folks on here that have they kick off their tests daily, essentially. We talk to a lot of shops where they essentially can't run all of their tests for every commit, so they run them overnight, right? Because assuming it takes 3-4 hours to run, you can only do that 2-3 times a day.
That's,
So
I mean, it's
basically
kind of
cycling through.
It's kind of frightening though, isn't it? Because you're basically not going to know till the next day if you broke something. And we're talking about, obviously, if you have your own unit tests and stuff, you've got confidence that your code works. But you never really know, particularly with a sufficiently complex system, i.e. something which has been developed for longer than 3 months. You don't know the knock-on effects you've had with some other system or some other part of your application. So I did kind of want to talk a little bit about I really hate sounding like a Develocity advert, but like these are the kinds of problems that I've really seen in the real world. And like Develocity has some really nice features to kind of help solve some of the long run times. But actually, before I wanted to do that, I did want to talk about how we speed up our tests in terms of using the -d skip tests option. And the other thing is about running stuff in parallel, because Gradle tends to run stuff in parallel by default, but a lot of Maven users don't realize that you can run the Maven stuff in parallel as well.
Yeah, and there's a couple options. So if you're on JUnit 5 or TestNG, a shout out to anybody still using TestNG. It used to be my favorite. But there's a lot of parallelization options that can run in a single JVM. So as long as your test can run concurrently, it's very fast. And then there's fork options, right? So you're essentially creating multiple JVMs to run your tests, which is still usually better than not running your tests in parallel.
Yeah, so like even out of the box, the build tools will allow you to sort of run stuff in parallel and help you do stuff. We will talk in the best practices about how to make that more effective, because once you start running your tests in parallel, if your tests are not well isolated, for example, or do depend on each other, things start to get very hairy quite quickly. And the other thing, so I wanted to mention the two things that we have for Develocity, which is test distribution and, 3 things. We've got build cache, we've got test distribution, and we've got predictive test selection. And I don't really have time to talk about any of these things. I'm just going to share my screen and have a quick, oh my God, where's the button gone again? It opens up on my teleprompter. My teleprompter isn't big enough for it. So, sharing the screen, opening the keynote. If you use a build cache, I'm going to mention these very quickly and people can go off and have a look at it later. But if you're using a build cache to cache the results of your build, which includes the results of your test, you can really decrease the time it takes to run your build and test, particularly if it's multi-modules. Because if you're only changing one module, then you may not need to build and test all the other modules. So Spring Boot, for example, went from like a 20-minute build time down to like a 3-minute build time just out of the box using build caching. And this applies to both Maven and Gradle. So I love the build cache because it's a kind of quick win, really. Obviously, if you make changes that kind of affect all the modules and you can't reuse stuff from the cache, then you don't always get the effects of the cache. But if you've made a small change, you shouldn't have to rerun and recompile and rerun all of your tests.
Hey, Trisha, just so you know, you've got the, I think, presenter view, it's called.
Oh, no.
I didn't even notice. I just am so used to staring at the presenter screen. I didn't even notice.
Thanks, Vinay, for pointing that out.
It's a good thing I didn't have anything embarrassing in there.
Right.
So
while you're trying to pull up your screen, we do have a course for both the build cache for Maven and build cache for Gradle build tool at DPE University, so you can check those out too. Oliver, you can stick the link in the chat.
Yes, I can.
I'll put you on the spot.
that's the Spring Boot build times going down. Build cache means you don't have to retest everything if you only change one area. Remote build cache is super cool. You should definitely check that out. Test distribution allows you to go like massively parallel. So if you're running tests locally, you're kind of restricted by the number of cores you have on your local machine. If you use test distribution and you have some test distribution agents like anywhere out there on the cloud or on your colleagues' machines, you can go much more massively parallel than just relying on the cores of your machine. So this will work for local builds and CI builds. So you can just automatically go parallel with your tests. And, you know, if you double the number of executors, you cut the build time in half. And then I don't really have a good one for predictive test selection. But predictive test selection is cool because it's machine learning to figure out which tests you really need to run based on the changes that you've made. And this is kind of what you want, particularly in a monorepo. You don't want to be running every single test when you've just changed 1 or 2 lines of code. So if you just change a few lines of code, predictive test selection will generally run around about half of your tests. It depends on how you've got it set up. So on this chart, for example, the red is the amount of time you spend running your tests, and the orangish is the amount of time that you would have spent testing if you weren't using predictive test selection. So this is based on some of our actual customers. So actual customer numbers, generally you don't have to run 50 to 60% of your tests using predictive test selection. Now, obviously,
and it's all about getting early feedback too. So you can still run all of your tests, but if you can run a handful of your tests to give you some confidence that yes, we think this thing works, then you're still ahead of the game. And then maybe you submit a PR and you run all of your tests or something.
Yeah, exactly. And so you probably want to run all of your tests when you're doing the release branch, for example. But on your local build, you want that fast feedback to make sure you didn't do anything really stupid, like share the wrong screen. Let's talk about testing best practices, because we've got about 8 minutes to do that.
Yeah, so we've got
we don't have a hard stop team. Don't worry.
we've got 30 minutes of content prepared for this section.
I do want to be able to be open to questions as well, though, because it's really important that we kind of answer people's questions. But the main thing we wanted to talk about was testing best practices. So I think the testing best practices leads into these slow tests, right? There's a number of different things, and I'm going to talk really quickly so I can kind of get as many of these things in as possible. And so, for example, not writing a boatload of integration tests and trying to focus on those fast, clean unit tests. In the Java world, we have a tendency to sometimes think that it's one class, one test, but it doesn't have to be that way. You can have like sociable unit tests where you've got multiple classes. You're just not relying on a database or an external service or anything that needs spinning up. You're just relying on the code. So a unit test is basically anything that runs quickly, like sub-second, sub-milli, sub.
I think most people, when they talk about unit tests, they're actually writing integration tests, right? So in the Spring world, if you spin up a Spring context, right, and that takes, I don't know, a few seconds to start up. Hopefully it's not a few seconds. So you start up your whole application, test a method or two, and then shut down the context. That's, in my mind, that's not a unit test.
Oh, I'm still sharing my screen, but I don't have slides. That makes sense. Sorry, folks. Yeah, no, a unit test should take milliseconds, right?
Yeah, minimal code interaction, minimal things you have to create. Again, I'm going to pick on Trisha's like 18 singletons. You didn't have to create all those things just to get some state in your application so you could poke at it. Hopefully you're testing, code in isolation, so method or the small interactions between a couple of classes.
And then the more you can rely on that kind of testing to do, that's really good for things like validation, right? If you want to test 500 different variations of some input, you really want to do that as fast as possible. You don't want to be spinning up an individual context for each one of those things. And then you can still have at like the end-to-end level or integration level, then you probably want your sanity checks, but you don't need to do every single bit of your testing where you have the whole application running.
Yep. And you don't have to. So if you're doing that today, I'm not saying you need to stop. There's like in the Spring world, there are a bunch of options to speed that up with like test slicing or reusing contexts. So there's still ways to get some performance out of what you're currently doing. But if you're starting to write new tests, some new functionality, then maybe you want to rethink your testing habits.
One of the other things that comes into this area, slow tests and slow tests and testing good practices, is one of the ways that people can try and speed up their tests is you have like, if you've got expensive setup, you might do the expensive setup once and then have like one test method which tests multiple things. And I get why people would do that, because if the setup is expensive, then you don't want to do that multiple times. But I really hate when test methods test more than one thing, because when it fails, you have no freaking idea what the test was supposed to be testing, or why it does that thing, or which part of the test it failed in. Particularly if you've got like 16 different asserts and they're all like assert true, which is one of my least favorite asserts. And then
no description.
No description. No description. So your test is called, test database connection, and it tests like 16 different things, and it's assert true, assert true, assert true, and it fails. You have no idea why that test is failing.
Yeah, I've definitely written a bunch of tests where, the tests were nice and clean, single line, assert, like, here's the expected, here's the actual, and then you have 15 of those, and then the third one fails. So what do? You comment out the first couple so you can like step through it. And then that works, but then the sixth one fails, right? So it's just really frustrating to have to do that. And it's toil, right? Stuff we don't have to do. Adding an extra test method costs nothing, right? And they're still going to execute about the same amount of time. So you might as well just, add a nicely named test method and continue.
And if your setup is really long, then that's probably a sign of a smell as well. You probably want to break that up into multiple things. I was reading Kent Beck in order to prepare for this, because Kent Beck is like the master of all of these things. So he was talking, I'm going to read them out. I don't think I'm going to share the screen, but he was talking about he's got an article called The Test Desiderata. Oh, that sounds I'm going to paste this in the chat actually. And so what he talks about there's lots of different properties of tests that you may have to like trade off against each other. For example, like I was saying, the separation of tests and isolation is good, but if the setup is really long, then your performance is going to be kind of slow. So the properties he was talking about is your tests should be isolated. They should be composable. By composable, it says if the tests are isolated, then I can run, it says composable. I can run 1, 10, or 100 or 1,000,000 and get the same results. They should be fast. They should be inspiring. Passing the tests should inspire confidence. I really like that.
Yeah, see, that's good.
They should be writable. Tests should be cheap to write relative to the cost of the code being tested. Readable, of course, comprehensible for the reader. Behavioral. Tests should be sensitive to changes in the behavior of the code under test. If the behavior changes, the test result should change. That sort of seems reasonable. Structure insensitive. Tests should not change their result if the structure of the code changes. This is one of the problems sometimes with unit tests, is if they're very tightly coupled to the implementation. If you do a refactoring, either the test, you end up deleting the test because it's invalid, or the test stops working because you have to mock so many things out to get to where you are. And that's very sensitive to
I think that's one of the things people complain about with mocking, right? If you're over mocking, then it's harder to refactor because of this exact same problem, right? You have to go, redefine all the behavior in your tests in 100 different places.
I can't remember if this happened to me or if this happened to my husband. We have a lot of conversations about testing and AI, and this happened in the last couple of weeks. One of us said that the AI had generated a unit test which was entirely mocking. There was like no actual code under test. And this is not just an AI thing. I've seen this in the wild as well, because once you've like refactored this and moved this over here and done that over there, you don't even realize that what you've done is just mocked out the entire test and you haven't called any production code whatsoever.
Yeah, so you're testing the mocking framework.
Yes. And that's a trap that it's easy to fall into. Right, structure insensitive, automated, specific. If a test fails, the cause of the failure should be obvious. And this is a thing where test naming is so important. Like, it sounds really dumb to care about test naming, but it's not, because when that test fails, the test is most valuable to me when it fails, which means it really needs to communicate with you. What was I expecting? What am I really checking for? What's the behavior that I expect to see? So that when I fail, it means that this behavior is no longer true. So if your test is called test insert, it doesn't tell you anything.
And then on the error side, so, either get really good at writing really descriptive messages. If you're going to assert true, then you need to have a really descriptive answer, or if you use something like Hamcrest or SearchA or one of those types of frameworks, the default message is usually pretty good. I still recommend making sure the test fails, so you see the error message or the failure message, so you know that, in 3 months from now, when you see that failure message, it has enough data that will help you figure out the problem.
That's a really good point. I always like to see a test fail. I do tend towards TDD, so I do tend to do reg read refactor. But if I write a test afterwards, which I do, and then it passes, the first thing I do is try and make the test fail, because I want to make sure it's passing for the right reasons and not because I forgot to put any assertions in there or something like that.
Absolutely.
The other two things that are in the list are deterministic, which is not flaky, and predictive. If the tests all pass, then the code under test should be suitable for production. The interesting thing he was saying about this is that you're not going to have a test which is all of those things. They're all a series of dials, so you turn them up and down. So like fast is your unit tests, but like readable for the business might be acceptance tests with a DSL, and they're probably not going to be fast because they're probably integration tests, end-to-end tests. So I really like this list because it's kind of specific about how testing is like any kind of architecture or design. There's a tension between the different things that you value. And this is why we have the testing pyramid, because you can't have just unit tests or just end-to-end tests. You need all of these different tests.
Yeah, so I know we're getting on time, but I want to point out one of my concerns for security. So I talk a lot about security in various circles, and I usually recommend using something like Dependabot, or pick your favorite, bot that updates your dependencies, right? It's great. Keep them up to date. However, if you do that, how do you know your test is your test? How do you know your code is going to work without tests, right? So a key part of your sort of security, the way you think about your code should be your tests. So you have to update a dependency, and then if your tests pass, that dependency is fine, right? And hopefully you're doing this all the time, and Dependabot probably spams you every Monday or whatever it is. But it's the only way to know if your updated code is working is if you have tests.
I reckon, like, Oliver will let us go a little bit later. I'm sure he will. There's a couple of other things I really wanted to talk about. One, I did want to talk about AI for generating tests, but I feel like we haven't really talked as much about best practices as I would like. So maybe, Brian, you could pick one piece of advice that you would give people when they're writing their tests.
Oh, put me on the spot. All right.
Okay.
My thing is make sure you can run a single test from your IDE. And that sounds really simplistic, but I worked at a bunch of shops where you had to write your code and they had to go to the command line to run some incantation of a Maven build or a Gradle build to get a single test to run, because you're orchestrating stuff in the build and out of the test. So that implies all the orchestration that happens is run at test time, not at build time. So it really helps you focus on making sure your tests work, and you can get that fast instant feedback as you're writing.
I think my piece of advice would be, because all these things are great. Things like isolation is so important, because you need to know that your tests aren't dependent on someone else's test data or aren't trampling over someone else's tests data. The other thing that Dave Farley talks about in terms of isolation is time isolation, which is probably still related to data. But like, if a test requires another test to run beforehand in order to set some state in the application or whatever, then that test is not isolated. So isolation is so important because it reduces flakiness if you have good isolation, but it also allows parallelization, because you can't guarantee those tests are going to run on the same thread, in the same JVM, on the same machine. So you want to make sure that your tests can be run not only like on their own, which your advice kind of comes to this, but you can run them isolated wherever they are. But also, like, you can run 16 of them at once without them trampling all over each other, because like I've seen that so many times.
Yeah, it's easy to get into habits, right? So I've seen a lot of tests that are hard code ports, right? All the tests use port 8080 or whatever, so you can only do one at a time. Or they set system properties, do something, and then set another system property. So that is potentially state across the whole system that you may run into issues, right? If you're testing feature flags or something.
Yeah, anything where you.
Problem.
Anything where you're using shared resources, you've got to be super, super careful. You kind of want to mock a lot of that stuff. When I went to LMOX, we actually used to mock the system clock, and it allowed us to do time travel. So you could, our application would ask the system clock, which is an external service, which you could mock what time it was effectively. And so then the tests could set it so that you could test things like end of day processes, or, like, you don't have to wait an hour for a particular state to change or whatever. So that was a really good way to get some reliability, but also speed up the tests.
That's really good. And in, if you're dealing with security like JWTs or those types of things, the clock comes into play there sometimes too. If you're trying to validate a token, or make sure the token is expired, then you have to adjust the what you think of as the clock.
Any of these time-based tests are just so difficult. Like, time is very difficult anyway. And we just tend to assume, well, we're going to need to rely on the time of the system, and you don't have to. You can mock that out. And one other piece of advice, which is I just love given, when, and then inside a test. I think it really helps avoid that trap of testing too many things at once in one method. So
even if you don't do the classic given, when, then, even I think I've seen some examples you've written is you just have a comment given this stuff, when this stuff, then this stuff.
Yeah. I mean, I like Spock because it forces you to do it. But if you're going to use JUnit or something, put a comment in there. It just really helped me and my team when we were testing big stuff. We were like, oh, no, this is the setup. This is not an assertion. Because sometimes someone mentioned in the chat soft assertions. So there's kind of a difference between an assertion, which is it must pass, and I think they're called assumptions, where you check kind of that the setup has been correctly set up. And you say, I do have Java 8 and I do have a database connection. And so if you've separated those into given, when, and then, you can tell a difference between, well, this failed on setup, so that might be an infrastructural thing, versus this failed in an assertion, in which case it's probably broken. Someone asked the difference. Oh, can you clarify what you mean when you're referring to a mock? Mocks aren't stubs. Oh, I don't want to go into that argument.
The state issue. Yeah, we can.
I think when we say mocks, we mean mocks and stubs. But in my mind, so a friend of mine gave me a definition of mocks and stubs. A stub is for putting data into your test. So you can have like a stub external system which will chuck stuff at you, and then a mock is something you can use to assert like outputs from your test, if you like. So you can assert that I did call out to this service and I did try and hit this kind of thing. But it all depends a lot. And I think for things like when you're talking about words like mocks and stubs and test harnesses and contract testing and all these things, the most important thing is that your team has a common understanding of what you mean by those words.
Yeah, I think that's key. That way, at least your tests are fairly consistent as how you handle those. I don't know. I've done a lot of mocking tests, and I've probably gone too far the other way. And then I've also done the stub option too, and I've gone too far that way. But if you don't have a lot of experience writing tests, I feel like going a little too far to figuring out what ends up being bad code, or when does this code start to smell, is a thing that's healthy, right? And then hopefully you fix it. But Go experiment, see what your patterns you like, see what works for your teams, and then read a bit. There's all kinds of this discussion, mocks versus stubs, is all over the internet.
Yeah, it's like, yeah. So I want to give time to have a look at what happened in the chat and to give Oliver a chance to ask us some questions, but I also want to talk about AI and tests. Should we do 30 seconds on AI and testing?
Yeah, or maybe 90 seconds, because the 30 seconds is gonna leak a little longer here.
So what are your thoughts on using AI to write tests?
That's my whole thought. Is just I think it's horrible. I think if I worked at a shop where we were generating SDKs based on like OpenAPI. We spent a ton of time making sure the code generated correctly, and then someone was like, "We should generate the test too." Right? I was like, well, what is the point of that? If you're generating the test and generating the code, what is it? What are you actually generating the test for? Right? Somebody has to validate that those two line up. So my whole thing is you shouldn't be generating tests. You should be writing the test, especially if you're generating code, because that way you know that the generated code is usable. right? Otherwise, you're just going to generate stuff and there's no human interaction. You're not going to know is the code easy to understand, right? Are you going to be able to understand this in 3 months from now?
Yeah. And
I think there are some exceptions here.
Yeah, I'm sure. Like everything it depends. But I think for me, my instinct is you can generate one or the other, not both. Like if you're using AI to create code, you should write the tests. And if you are using or if you've got legacy code that works the way it works, it may not work perfectly, but it works the way it works. It has a understood set of behavior. Then you can generate tests for that code because the tests will test the code works the way it does. And it already works that way. The reason I don't like using AI to generate tests for new code is because the AI will only generate code for tests that will only generate tests that tests the code works the way it does work. It doesn't generate tests that set down the expectations of how it should work. And that's my problem with AI.
Right. So if you're generating tests for your legacy code, that's great. But you're also testing that whatever bugs are in your code base are bugs, right? So the tests are testing that the bug is there,
right?
Not that the bug isn't there, which is normally what we want to write tests for.
Right. So, Oliver, actually, we need to close the poll, don't we? Are there questions that we need to answer before we finish all of this?
Yeah, there's a couple nice questions in here, scrolling up a little bit above before can you clarify what you mean when you're referring to a mock rabbit hole that Jacob tried to bring us down? There's a question from Amadi. Do you consider integrating mutating tests as a must-have when writing unit tests?
God, no. Mutation tests are really hard. They're very difficult. They're very time consuming. I do think they're very, very valuable. They can find some really interesting bugs and cases. And maybe mutation testing might be something which could help us with some of the AI generated code in the future. I'm not really sure. It's also a potential way of finding which tests aren't adding any value. Because if you use mutation testing and find that your tests never fail, then you're like, I don't think these things are actually doing anything. So mutation testing is really valuable. But I spent a bit of time looking at mutation testing last year to figure out if we could use it to delete tests, basically. And because what it does is like it goes through all of your tests and one by one changes them ever so slightly and then runs them all and then changes them ever so slightly and then runs them all and changes them and runs them all. It's a very CPU intensive and time intensive exercise. So until this gets more efficient, it's not something I would expect most people to be doing.
Yeah, I would agree. Unless you have a need for it, there's something you're trying to get out of it, I wouldn't worry about it too much.
And someone made a good comment. It changes the tested code, not the test. Yes, you're right. It makes the change and then runs all the tests again. The point is, if your tests always pass when your code has changed a lot, then your tests are probably pointless and you want to delete them. But the same thing. The same thing applies. Like it makes a small change and runs everything again and again and again. More questions?
There's another question, or rather, there's a comment from Jacob saying you can describe in plain language what you want your test to check and have Copilot or other tools fill in the blanks. For example, write a test that covers edge cases. How do you see that working?
I think AI is good for considering things like edge cases. I've used it to generate some unit tests, and it came up with cases that I hadn't thought of. Again, it's good for creating tests for code that already exists, and it's good to check the code does what it does. It's not always great at going outside of the box and going, hey, but wait a minute, maybe the business never even wanted it to be read in the first place. And that our job is to step back and go, what is it that we really expect the system to do?
It's also a suggestion too. So if your Copilot suggests this test, you should read it, validate that it's something you would write, maybe tweak it if you have to, but then accept that test as something you would have written. So that's different than just blindly generating tests and calling it a day as well.
Oh, someone's filled in the rabbit hole of dummies, fakes, and stuffs. Okay, great. So we know how to do that.
Nice.
What else, Oliver?
I think we're pretty much there in terms of answering questions. Let's since we're running out of time, why don't we hop to our lightning round? Now, if you're not familiar with a lightning round, The idea is that each speaker gives a very, very brief answer, less than 10 words, for example.
Oh, God.
And they do it as fast as possible.
All
So,
right.
Brian, let's start with you. What is the best part of being a developer advocate?
Oh, I think talking to folks. So the hallway track is my favorite thing at a conference.
Trisha.
Damn. Well, I was going to say the same thing. It's all about connecting. It's being able to talk to people other than the people in your company. So you get a really broad network.
Great. What was your first IDE and what is your current choice nowadays? Brian.
Oh, probably NetBeans or maybe Borland JBuilder in IntelliJ right now.
All right. Trisha.
Well, I think my first IDE, because I used Turbo Pascal at school. So probably Turbo Pascal was my first IDE because it's all built into the same thing. And then when I went to Java, I used Vi like everyone else did. And obviously, IntelliJ IDEA is now. Thank you, Oliver, for that question. That's amazing.
Yeah, no problem. All right. Trisha, how about you? Tabs or spaces?
Spaces.
Brian.
Spaces. Yeah.
All right.
I don't even think this is a debate anymore.
Well, you've just rekindled it. So congratulations. Trisha, who is someone you admire in the Java ecosystem?
Oh, man, I should have read these questions beforehand. God, there's so many people I can't even pick them. I'm going to say Angie Jones, particularly because we're on the testing thing at the moment, and she's done a whole bunch of really interesting stuff around testing, good automated testing. She's got a whole bunch of courses on teaching people how to do Java, how to use IntelliJ, how to do testing well. She's brilliant.
Brian.
All right, I didn't read these early either, but I'm going to cop out and say Kent Beck because Trisha's talked about him multiple times already, and I kept looking over my bookshelf and seeing one of his books there too, and I've definitely learned a lot. Even so, one of the books I have from Kent Beck isn't even about testing, and I learned a ton about testing from reading that book, so it's been great.
I probably should mention Dave Farley though, because he does let me on his YouTube channel.
You're ruining the lightning round.
Right.
Trisha, what is a book that you think all developers should read?
Oh, yes, I've got one of those.
Getting to know IntelliJ IDEA. Now, I think we're one of the authors you know pretty well.
I know both of the authors pretty well.
Yeah.
And yeah, if you ask me nicely, I might give you a discount code.
All right, Brian.
My book collection is a little older, and now it's trending towards like behaviorism things. But I do think if you're working at a company that spans multiple countries, the cultural map is really good, and it helped me. And Trisha probably have that behind there too. Yeah, it helped me understand a lot of the things that were floating around in my head. But each culture operates differently. Americans are pretty forward. Some folks are reserved. And that's totally fine, and we just have to understand that people are different. Suck it up, so to say.
And now for the most important question of all, Trisha, vanilla, chocolate, or strawberry?
Vanilla.
Brian?
I'm going to go with strawberry, but I would not turn down vanilla.
All right. Well, Trisha and Brian, it was really great learning with you today. This was a lot of fun, and I hope we can do this more often. To our audience, thanks for joining us. And please do give feedback in the Zoom survey that should pop up when this is over. See you next time.
Bye, everyone.
Bye.